Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on multiplying and dividing in algebra. So in algebra we see lots of expressions. So we see different expressions like the following. So you might see things like x cubed or a to the negative 2 or y to the 0. So anything to the power of 0 you know is equal to 1. But so you might see, now this is an equation, that's not an expression, so I'm just going to take this part out. That's just a side note for you to remember that y anything to the power of 0 equals 1. Okay. So you might see different expressions. You might see things like x squared y cubed w to the negative 1, or this could also be written as x squared y cubed over w to the 1. Okay, so these two are the same, they're just written in a different way. Or you might see expressions like m plus n to the 5, etc. Okay, so what we're going to cover in today's lesson is how to multiply, and then we're going to cover how to divide these types of expressions when you're doing questions in algebra. Okay, so let's start off with just a simple example. Now let's say you're multiplying. Now you already know that a to the power of n means a multiplied by itself n times, right? So if you have, say, x2 times x3, now when you have the same base and you're multiplying, all you have to do is just add the exponents. Okay, so this becomes x to the 5. Okay, so a general rule that we can write is x to the a times x to the b is equal to x to the a plus b. So that's a general rule in algebra that you want to remember. Okay, so that's basically that when you're multiplying two things with the same base, you just add the exponents. And we can use this rule to do a whole bunch of examples. Like if I did x times x cubed, it could be written in this way. If there's nothing written here, there's always a 1. Okay, so in that case it would be x to the 1 plus 3, which would be x to the 4. Okay, or this could be written as x times x3. And again, that's just x to the 4, 1 plus 3. Okay. Now we could have something like the following. Say you could have x to the 5 times, say, x to the a. Okay, so in this case, again, you just write x and then you write 5 plus a. But in this case, because 5 and a are not like terms, you can't simplify it any further from that point on. Like in this case, we had numbers, so we were able to add. But over here, 5 and a are not like terms, so the final answer would just be x to the 5 plus a. Okay, so we're going to do a few more. So let's just write that rule again at the top of our page. So the rule is basically that x to the a times x to the b is equal to x to the a plus b. And that's a general rule that we always follow in algebra. Okay? So once we have that down, we can do any question. I mean, if you're given y to the 2 times y to the n times y to the 3. Again, you just collect, it doesn't matter how many you have, you just add the exponents. And in this case, you can add the 2 and 3, and then it would just be 5y to the 5 plus n. Because n is not a like term to 2 and 3, you wouldn't be able to add those. So for that, you could look at the lesson on like terms. Okay? So really straightforward, just basically when you're multiplying, you know, a to 2 times a to the 1 times a to the, you know, negative 7 or something. So in this case, again, you just add the exponents, plus 1 plus negative 7, right? So in this case, it would be a to the 3 plus negative 7, which would be a to the negative 4, okay? So something like that. So you're just, when you're multiplying, and these just represent multiplication, you just add the exponents. That's as simple as it is. If you're given something like a times 1 over a cubed, in this case, you know, if you wanted to express these with the same, with, you know, just as a base of a, I mean, you could go ahead and just write this as a over a cubed and then simplify it that way, or you could write it as you know, a times a to the negative 3. So you could write this as that. Now that's a general rule. I'm going to put that in here as well. That if you have something to the power of negative, let's see, how do we write this here? Negative n, that can be written as 1 over a to the n as positive. Okay, so if you have 1 over a to the positive, like if you have it, a fraction in that form, you can rewrite it as a to the negative n, like that. So, you know, something like that, we could just write like that, and then at that point, we're just adding exponents. So this is 1, so 1 plus negative 3. So that would be a to the negative 2. And then if you wanted, you could rewrite it like this again, or you could just keep it like that. Okay, or we could have gotten the answer in a different way, but we'll just do it that way right now. So that's the rule for adding, and for dividing, sorry, for multiplying. And for dividing, it's the basic general rule is x to the a over x to the b is just equal to x to the a minus b. So when you're dividing two things with the same base in algebra, you just subtract the exponents. Okay, so that's another general rule. So that's an a there. So this one could be applied to any example. So if you had, say, x to the 5, you know, divided by x to the 3, that would just be x to the 5 minus 3, which would be x to the 2, okay? You know, or it could be written as x to the 5 divided by x to the 3. So again, you're dividing, so it would be x to the 5 minus 3, which would be x to the 2. Okay, so these rules always hold in algebra. So important rules to remember. So that first one there and this one right here. And then, of course, this one also is good too, because if you have 1 over 8, something to the power of a number, you could always write it as a negative exponent and just get rid of the 1. Okay, so that's just another thing to remember for notation. So let's try some more examples here. So say you had, you know, y to the 4 divided by y to the 6. So that would just be y to the 4 minus 6, which would be y to the negative 2. Okay. So, I mean, you could get examples where you have, like, more than one variable. Okay, so like when you're multiplying and dividing. So let's put the general rules here first. So we have x to the a times x to the b is x to the a plus b. And then x to the a divided by x to the b is x to the a minus b. So if you're doing, let's say you have like something like this, a squared b cubed times a5 b7. Okay, so say you're multiplying these two. Okay, now in this case, what you do is, again, you look for the variables that have the same base. So in this case, you've got a squared and a5, so you take those two and you just add the exponents. So 2 plus 5, so it becomes a to the 2 plus 5. And then over here you put the b, and then you do 3 plus 7. Okay, so that would just be a to the 7, b to the 10. So you have to do the different variables like separately. Okay, so that's how you would multiply something like that. You know, you could have x, y, z, w to the 7, 3 or something, and then multiply that by x squared y, z, w. Okay, so if you're asked to multiply this, again, you just do, okay, so this has, if there's nothing written, there's a 1 here, so x to the 1 and x to the 2 becomes x to the 3. You just add the exponents, and then when multiplying here, you've got 1 and 1, so that becomes y to the 2, and then z to the 3, there's actually a 1 here because nothing's written down, so that becomes z to the 4. And then over here, we've got w to the 7 and w to the 1, so that becomes w to the 8. So you add the exponents. So you use the same rule, okay? And this always holds in algebra for multiplying, you know, expressions or variables, okay? So it's important to keep that in mind. So, and we can do some for division too. I mean, we can try a few different ones. Now, I want to show you a few other ones here. Like, let's say you're multiplying x to the n minus m times x to the, say, n plus m. Okay, now over here again you've got the same base. So when you're multiplying two things with the same base, you just add the exponents. So you take the exponent n minus m and you add the other exponent. Okay, so at that point, now you're just, collecting like terms over here. So this here, I mean, when you open up the brackets, just still positive n positive m. So you get x to the n plus n, which is 2n, and then negative m plus m is 0m. So your final answer is going to be x to the 2n. Okay, so even for things like this, just looking at the base, you would just add the exponents. And to add, of course, we use the rules of, adding and subtracting in algebra, which are that you have to have like terms in order to add, right? So that would be the answer for that one. Okay, so, and if we were doing, say, division, let's try some division examples. So say you had a to the 4, b to the 3 over divided by ab squared. Well, again, when you're dividing, what's the rule? X to the a over x to the b is equal to x to the a minus b, right? And for multiplication, it's just adding. Times xb is x to the a plus b. So those are the rules there. So in this case, you just collect the, a, and then the ones that are common. Now, if there's nothing written, there's always a 1. So this becomes 4 minus 1, and then this becomes b to the 3 minus 2. So it's kind of like the opposite rules of multiplying. Instead of adding, you start subtracting the exponents, okay? So then this becomes a to the 3 and b to the 1. And when there's a 1, we usually don't write the exponent, so that just becomes a 3 to the b. Okay? This could have also been written as the following. Like, it could have been written in this form too, and that would have still given us the same answer, because we're still doing a4 divided by a1, which is a3, and then b3 divided by b2, which is just b to the 1. Okay, so that would give the exact same answer. Okay, or say we did a division question where we had like y to the n minus m divided by y to the n plus m. So because we're dividing here, we just collect y and we do n minus m. So because it's division, I now have to subtract the second part, remembering to keep it all in brackets. Okay, that's important, because now when I open up the brackets, I get n minus m minus n minus m. So this negative goes into both. Okay, so it goes into both, and at that point, n minus n cancels, and over here you're left with y to the negative 2m as your final answer. Okay, so that would be the answer for that one. And these rules never change, they're always the same, so that's a consistent rule in mathematics, in algebra. Okay, so let's do a couple more. Now, what if you have a power raised to a power? Now, so now we're going to go over a different rule here. So when you've got something like x to the a all to the power of b, something like that, what happens here? Now this is different than the other rule. So the other rule was x to the a times x to the b is equal to x to the a plus b, and then we had x to the a divided by x to the b is equal to x to the a minus b. Now this rule here is when you have another power. So in this case, what happens is these two actually multiply each other. Okay, and this is assuming that x does not equal 0, of course. Okay, and this is the rule for quotients, like in algebra. Okay, so this is another rule you want to keep in mind. Okay, now this here, so now if we were applying this example, so say you wanted to evaluate or simplify something like x squared to the power of 3. Now that would just be x to the 2 times 3, which is 6. Okay, so that's how you would do that one there. Okay, we can try like a few more. So if you had, say, w to the power of 5 multiplied by 2, or to raise to the power of 2, what happens is these two multiply and it would become 10, not 7. Okay, so you have to watch out for that. So this is different than w to the 5 times w to the 2. In that case, it becomes w to the 7. You add the exponents because you're multiplying two things with the same base. Now these two are not the same question. This is different than this, okay? So these we're multiplying two things with the same base, and then we add their exponents. Over here we've just got one base, but we've got 5, and then we've got it raised to another power of 2, so it becomes w to the 10. Now if we had a to the negative 3 times 2, raised to the power of 2, again we would just multiply these two. So negative 3 and positive 2 would be negative 6. Okay? And even if you had a number, I mean, even if you had like the number 2 here, and you had 2 to the 2 to the power of 3, same rule holds for numbers. So that would actually be 2 to the 6, which would be, 64. Okay? So it even holds for numbers, and we see it like in, these rules in, say, like scientific notation. If we had 10 to the 4 to the power of 3, that would just be 10 to the 4 times 3, so it would be 10 to the 12. Okay? So that's how that would work. And even in numbers, if I was using the other two rules, like if I had 10 to the 3 times 10 to the 2, again over here it's 10 to the, and you add the exponents. So that would be 10 to the 5. So you're still using these rules even with numbers, okay? Or if we were dividing 10 to the 3 divided by 10 to the 2, that would give us 10 to the 3 minus 2, which would be 10 to the 1, which would just be 10, okay? And that's using this rule here. So it applies for numbers also. This is a little bit different. This is just one base, and it's raised to an exponent and then raised to another exponent. Okay, so that's why that's rule number 3. It's a little bit different here. So that's this rule right here. Okay, that's another rule that you have to know to be able to do questions in that. Okay, so let's try some more examples here. Let's go over some more rules, I should say. So actually, sorry, I want to do one more example there with that rule. So the rule was x to the a to the b is equal to x to the ab, and that's where x does not equal 0. Okay, so like say you had b to the x plus 2 all to the power of 3. So in this case, it's going to be, again, this thing's going to multiply here and here. So it's going to be 3 times x plus 2, right? And that just goes here and here. So that becomes b to the 3x plus 6. Okay, so the 3 multiplies into both terms there. But because these two are not like terms, we can't simplify what's inside of the bracket. And but we do, when we open up the bracket, we do have to multiply whatever's in front of the bracket into both of the terms inside of the bracket. So that's how we get b to the 3x plus 6. Okay. I mean, say you had x, y, z all to the power of 5. Now, because there's nothing written here, there's actually a 1. So what happens is this rule applies, and the 1's get multiplied by 5. So it becomes x to the 5, y to the 5, and z to the 5, if you simplify something like that. If we had, say, 2x all to the power of 3, this rule here is going to apply. Now the 2 actually has an exponent of 1 that's not really written down. So I'm going to just write that here. There's a 1 here and there's a 1 here that you don't see, okay? So what happens is when you're multiplying something like this, it's going to multiply into both those exponents. This rule here applies to both exponents. So what happens is it becomes 2 to the 3 and x to the 3, okay? And then you could even like simplify that. I mean, this you can simplify to 8. Oh, sorry about that. So this you can multiply to 8x to the 3. Okay. And say we had something like the following. if we had, say, 3x squared y to the n all to the power of 3. So that's, there's actually a 1 with there, so that's going to go into that. It's going to go 3 to the 3x to the, and then these two don't get added, they get multiplied. So that becomes 6, and it becomes y to the 3 times n is just 3n. Okay, so that becomes y to the 3n. And then you can actually simplify this. So 3 times 3 would be 9, so that would be 27, x to the 6, y to the 3n. Okay? When you're multiplying two things that don't have the same base, you do have to write them separately. So if you're multiplying a number with a variable, you just write them beside each other. Like, okay, so I'm just going to go into a little bit detail about that. So like what I'm trying to say is when you're multiplying, say, 5 times n, it just becomes 5n. Whereas like, or if you're multiplying x times y, you would just write that as xy. Okay, when you're multiplying. But if you're multiplying, say, x times x to the 2, now because you have the same base, what happens is your exponent becomes x to the 3, and you get the same thing in there. Okay? So that's how that works. If you do x times x, y, z, this x and this x becomes x squared. The ones, you add the exponents and you just collect it with one, 1x, and then the y and z just attached to that. So that's just how you would be multiplying in algebra. Okay, so a few other examples could be like if you had 5n times 3n, that you would multiply the numbers, so that would be 15, and then the n, you would use that rule where you add the exponent, so that would become n to the 2. Okay. So that's how that would work. So, just trying to see here what other examples I can do here. So if we have like 2y squared times x, that would just be equal to 2y squared x. If you had 2y squared times y, 5, now what would happen there is you get 2, and then the y's, you would just add the exponent, so you get 2y to the 7. Okay, so if they're different bases, you can't actually like combine them into one thing. You just write them beside each other. Okay, so that's how that works there. If I did x times y times z, that just becomes x, y, z. Okay, if I did x times y squared times z squared multiplied by, again, by y, it's 4 times x to the 2. If I was multiplying all of these, what I would get is x to the 1 and x, so that would be x to the 3, y to the 6, and z to the 2. So I could rewrite this as the following. So what you do is you kind of compress it, so you have this, like all the variables that go together, you combine it into one, and you raise the exponent. Okay? So if we were multiplying 2xyz multiplied by 4xy w, that would just be 8x squared y squared and then zw. So you would just raise these two, you would add the exponents, and then over here you'd add the exponents there to 2, and then you just attach the z and the w. If I had 2xyz times, 3 x squared y squared z. Now in this case, again, multiply the numbers, and then x to the 1 times x to the 2 is x to the 3. And then y to the 1 times y to the 2 is y to the 3. And then z to the 1 times z to the 1 is z to the 2. So you just add the exponents, so that becomes z to the 2. Okay, so just adding the exponents there. And the rule we're using is x to the a times x to the b is equal to x to the a plus b. We have the same base. Okay. We could do division. I mean, if you were, so this is, let's stick to multiplication first, but, so that's how you would multiply. But if you were, say, dividing, so if you had, you know, okay, so let's now try some division stuff. So say you had 7xy divided by x. In that case, the 7 and the x's would cancel, and you get 7y. So it would be x to the 1 minus 1, which would give x to the 0. And if I actually wrote this step by step, okay, so if I actually wrote down step by step, this would be x to the 0 times y, and anything to the power of 0 is always equal to 1. So x to the 0 equals 1. That's another rule to remember in mathematics. So what happens here is this becomes 7y. Okay? Or say we were, you know, doing 4x, y, z, and these were all, you know, squared and cubed, and then we were dividing by 2x, y, z. Now in that case, we would just divide the numbers, and then here, because we're dividing now, we subtract the smaller one from the big one, so 2 minus 1, so it becomes x to the 1, and then y to the, I'll just write it down here, 2 minus 1, y to the 3 minus 1, the bottom one there, and then over here is z to the 2 minus 1 because of the 1 here. That's not actually written. So if it were 0 here, this wouldn't even be here because it would just be 1. So that's why you always assume a 1 for each variable if nothing's written as their exponent. So this becomes 2 to the x, y squared, and z to the 1. Okay, so that would be the answer for something like this if you had to simplify something like that. Okay. And you're going to also keep in mind the following. When you have x to the a times b, and you get x to the ab, that's the same as x to the ba. So that's just the rule when I was mentioning with multiplication. Doesn't matter what order they are in. Okay. So again, like if you had 10a 5b divided by 5 to the a, something like this. So you would just do 10 divided by 5, which is 2, and then a to the 5 minus, so it would be a to the 5 minus 1, which would be a to the 4, and then b would just be written because there's nothing on the bottom there. So that's how you would divide something like that. Okay, so if we had like x 6y 10 divided by x, you know, negative 4 y negative 3, something like that. So you just collect the base and you're subtracting the exponents. So it becomes 6 minus negative 4, and then y to the 10 minus, and then because it's a negative, you want to write that in brackets. So this becomes x to the 6 plus 4 and y to the 10 plus 3. Okay, so that would become x to the 10, y to the 13. Okay, so that would be the answer for something like that. Okay, so if we were multiplying, say, x, y, z to the 3, 4, 4 times, say, x to the 4, y to the negative 2, and z to the 3. So now in this case, we would just do x to the 3 plus 4, y to the 5 plus negative 2, and then z to the 4 plus 3. So you'd collect everything with the same base, and then you would just add their exponents. So this would become x to the 7, y to the 3, and z to the 7. Okay, so that's how you would simplify something like this. If we had something like 5a squared b times b, say, and we're just multiplying those, well, that would just be 5, and then a squared, and then b to the 1 plus 1. So you're adding those ones there, so that would become 5a squared b squared. Okay? So that's like multiplying and dividing. Takes a lot of practice, really. You want to try different questions out. Now we can do a few of the exponent questions. So say you have x to the 3 to the exponent of negative 2 or something. So then again, because it's now this is different, this is raising this to different exponents, that would become negative 6. You would multiply these. Okay, or if you had like 2x cubed y to the 2z all to the power of 3, that would become 2 to the 3 x to the, this gets multiplied. So a common error here is students usually think that x to the 3 to the power of 3 is x to the 6, but that's not correct because you're not multiplying x to the 3 by x to the 3. You're taking x to the 3 and you're raising it to the power of 3. So you're actually using this rule here. Okay, so that's the rule. You're not using this rule. Okay, so in this case it becomes x to the 9, and then y to the 6, and then there's a 1 here, so that becomes z to the 1 times 3, so that becomes 3. Okay, so that's how you would simplify, something like this with an exponent. Okay. And you could be given questions where you've got multiple things going on. Like, you could have this same thing, y to the 2z to the exponent, and then you've got 2x, y, z, or something like that, right? So, and say that had a power of 2, and you were asked to simplify something like that. So in that case, again, what you're going to do first is bring in, and you're going to follow BEDMAS, because before you, it's funny because BEDMAS comes into play again, even in algebra, and you're going to follow the rules of BEDMAS. So you're actually going to be doing the exponent before you do the multiplication. Okay, so that's why you're going to deal with the exponent first. So you're going to bring in the exponent. It's going to become 2 to the 3, x to the 9, y to the 6, and z to the 3 times, and then bring this one in, remembering to bring it into the number as well, because there's actually a 1 here, even though it's not written down. So if there's no exponent attached to a number or a variable, there's always actually a 1 there that we don't see, okay? So this becomes 2 to the 2 here, x to the 2, y to the 2, and z to the 2. So you deal with the exponents, and then before you start multiplying, even here you can simplify these. Like this could be 8 x9 y6 z to the 3 times 4x squared y squared z squared, and then when you multiply these you're going to get 8 times 4, which is 36, and then x to the 9 times x to the 2, so that's when you start adding the exponents, right? So that becomes 11, and then y6 times y to the 2 is y to the 8, and then z 3 times z to the 2 is z to the 5. So you add the exponents, right? So you're adding the exponents when you have the two bases there in the question. So this is a good one here. Okay, and we could have even done like a division question like this as well. And before you do the division, you want to deal with the exponents first again. I'll show you maybe a division example. So maybe 2x, y, z all to the power of 3 divided by 2x, y, z to the power of 2, say. So again, in something like this, you are going to be following BEDMAS again. So you're going to deal with the exponents first. And to do that, you want to use the rules. X to the a, b is equal to x, a, b. And when you're multiplying similar things with similar bases, you're going to use the other rule, which is xa plus b, right? So those are two different rules. In division, you do xa divided by x to the b is x to the a minus b. When you're dividing two things with the same base, then you have to subtract the exponents. So in this case, we would deal with the exponent first. Okay, so we would actually get, just delete this part here. So over here, you would actually get 2 to the 3, x to the 6, y to the 3, z to the 3. So I just, the ones get multiplied by 3, okay? Over here we get 2 to the 2, x to the 2, y to the 2, and z to the 2. Now at that point we could, simplify the numbers. So we get 8x6, y3, z3 over 4x squared, y squared, z squared. So now we could go ahead and divide this, and this would become, now when we're dividing, we subtract, we have the same base. This becomes 6 minus 4, y to the 3 minus 2, z to the 3 minus 2. And then this here becomes 2x to the 2, y, and z. So that would be your answer for that one. Okay? So that's how you divide something like that out. There's so many examples to do. So let's just close this one here. You can be presented with so many different types of questions, but if you have a solid understanding of the base rules, and this is what I was mentioning in my first introduction video on my channel, is that with math, it's the rules that you really have to imprint, and you have to know those rules. And when you do know those rules, then you can tackle any question that you're given. Any question. I mean, they're all doable. It's just once you have a solid understanding of those base rules, then any question is doable. So say you were given a fraction type situation, and you had a 3. So again, you're just going to bring it into both of these. So this is going to become 8 over 27. Okay, so you bring the 3 into these, both have an exponent of 1, even though it's not written there. So you bring the 3 into both, and you will get 8 over 27 there. Okay, so if I had x, y, z all over 5, and I had that to the power of, say, 2, and maybe this was to the raised to the 2, say. So now I would bring this 2 into everything. So it would become x to the 2, y to the, so these two would get multiplied. So I'm still following this rule here. So this would become y to the 4, and then z to the 2, because there's a 1 here. And then this 2 would still come to the bottom as well. So we become x to the 4, y to the 4, z to the 2, all over 25. So that would be this one here, simplified. Now, I had just mentioned another rule that I want to quickly go over, and that was that x to the power of 0 is always equal to 1. So anything to the power of 0 where x obviously does not equal 0. So I should mention that as well. Okay, so if you have anything in math raised to the power of 0, it's always 1. So a to the 0 is equal to 1. 1,000 to the power of 0 is equal to 1. X, y, z all to the power of 0 is equal to 1. Okay, so I mean, even if you had something like x squared minus 3x plus 5 all to the power of 0, still equal to 1. Okay, so that's how that rule works. So this is another rule that you have to remember in mathematics. Okay, now if we had, say, let's just start a new page here. So if you had, say, 5x to the 0. Now in this case, this whole thing is not 1 because this is not in brackets. So that 0 only applies to the x. This 5 has a 1 attached. So this is equal to 5 times 1, which is 5. Okay, but if I had 5x all to the 0, that would be equal to 1. So you have to see the way it's written. If it's written this way, the 0 just applies to the x. okay, not to the 5. The 5 has a 1 there as an exponent. And the other rule I was mentioning, which is important to remember, is when you have x to the a, or let's say negative a, x to the negative a is equal to 1 over x to the a as a positive. Okay, so that's another rule to keep in mind. And again, x does not equal 0. We're not, so 0 to the power of anything just equals 0. So that this rule does not apply when we're dealing with 0 as a base. So that's another rule to keep in mind. And this applies for numbers or anything. So if you have like x to the negative 2, you can just write that as 1 over x to the 2 to make it positive. Or if you had, say, like 10 to the negative 2, you could write that as 1 over 10 to the positive 2. Okay, so you can use it for numbers or variables. Okay, and now we're going to do a few more rules here. So if you have, say, x over y all to the power of n, what happens is that exponent comes into both of those. So that's another rule to remember, and that's where y does not equal 0. If the bottom of this fraction equals 0, that would be undefined. So you don't want a situation where the bottom is equal to 0 in the fraction, okay? So that would mean that it wouldn't exist. So that's why y does not equal 0 for this rule. So this is like the examples we were doing. If you have like a over b, you know, to the power of 3 or something, you've got 2 here. You do just bring this exponent into both. So it would be a to the 4, b to the 2 times 3, which is 6. Okay. If I had a number, say I had 2a over b, let's put 2's here, say, and it was raised to the 2, that 2 would even apply to this, so it would become 2 to the power of 1, so it would become 2 to the 2, a to the 4, b to the 4, so it applies to everything. Whoop. Sorry about that. It would apply to everything in here and here. Okay, so that would become 4a to the 4 over b to the 4. And then we can't really simplify this because a and b are different, but if they were the same, we could have simplified further. Okay, let's see here. So if we were just to try out, some general, and I just want to show you a couple of things that you could use this rule for here. So x to the negative a is equal to 1 over x to the a, where x does not equal 0. So say you were, given something like 1 over x y to the negative 2, that could be rewritten. If you wanted to write this expression, so like say the question was to write without negative exponents, right? So that would just be, in that case, this one here would be y to the 2, you would have 1 over x, and then if you brought the y up, it would become y to the positive 2 over x. So you could rewrite it like that, okay? Or like if you have 5 to the negative 1, that you could write that as 1 over 5 to get rid of the negative exponent. And you could work backwards as well. If you've got a fraction and you want to write it as an exponent, you could write it like this. I mean, if you had 1 over x and you wanted to write x just with the base of x, you could write this, and there's a 1 here. You would write this as x to the negative 1. Okay? So that's you can go back and forth with that rule. If you had 1 over x to the 4 and you wanted to write that as just a base of x, that's x to the negative 4. Okay? So that's like how that works. So there's going to be different questions where you're going to want to flip back and forth and use different methods depending on what you're dealing with, what type of question. So we could do a few examples of simplifying. I mean, like if you get something like, these are similar to what we've already done. So that's the main rules there that I covered. There's 7 rules that you really need to know well. And I can just I've been just writing them over and over, but those 7 rules that I kind of wrote down in boxes, you've got to know those by heart. And then you can just apply them to anything. So you can, given any mathematical question, you can just simplify it using those rules. So, I mean, if you're given, say, y to the 3 times y to the 2 times y to the 4, well, using that rule there, x to the a times x to the b equals x to the a plus b, you could just say this is equal to y to the 9, because you would just add the exponents, right? So that's one. If you had, say, x to the n plus 1 times x to the 2, that would just be x to the n plus 1 plus 2, so it would be x to the n plus 3, right? So that's another one. If you were asked to simplify x to the n plus 2, or divided by x to the n plus 1, you would just write that as x to the n plus 2 minus n plus 1. Okay, and that would be the other rule for division. When you have the same base, you just subtract the exponents. So that would be n plus 2 minus n minus 1. That would go into both. And that would be x to the, so these would cancel, and 2 minus 1, so that would be x to the 1, or just x. Okay, so that's another one. If you had something like x to the negative 2 divided by x to the negative 3, that would just be negative 2 minus negative 3, but you would keep that in brackets. So that would become x to the negative 2 plus 3, which would be x to the 1. Okay, so we would just write that as x. Now if you had something like x to the 3 to the power of 4, that would just be x to the 12, so you multiply. Okay, so this is just now applying those rules to actual questions. If we had x to negative 2 times negative 2, we just multiply the exponents, so it becomes positive 4. If I had something like 9 to the 2 all to the power of 3, that would become 9 to the 6. Or say we had x to the a plus 1 all to the power of 2, that would just go into both, so it become x to the 2a plus 2. Okay. If you have 2x all to the 3, that's going to go into both. So it's going to be 2 to the 3 and x to the 3, so that becomes 8x cubed. Okay. Okay, so just multiplying, dividing in algebra. There's a lot of other examples that could be done, more complicated examples. Like I had done some in the previous part of this lesson, so you can try those types of questions as well. When you're multiplying something like, just want to go over something else here. If you got like a number and you've got x plus y, you have to bring that in, so that's going to become 5x plus 5y. Okay, just another rule I wanted to go over. If you've got, say, 5x times x plus y, that 5x is going to go into both, and then you're going to use the rules of multiplication. So this is going to become 5x squared, and then 5x times y is just going to become 5xy, and you have to write that plus sign in there as well. Okay, so simplifying things like that, 3a squared b times a plus b, that's going to multiply here and here. Let's put a number on that one. So this is going to become 6a cubed b. So a squared and a to the 1 become a to the 3. The b attaches, and then over here we've got plus, and then we get 3a squared, and then b and b, because they have the same base, we would add their exponents to 2. So it's 1 and 1, so it becomes a 2. Okay, so that's how that would work there. Okay, now Yeah, so I think we should leave it at that because that's quite a bit there. Okay, I'm going to do another lesson in more detail on multiplying algebraic expressions, and then we're going to start using things like FOIL and etc. So that's going to be another lesson. So I hope this helps you understand the basic rules of multiplying, dividing in algebra. And like I said, those 6 rules are important to know, the ones I put in boxes. If you have any further questions, you can post them on the channel page, but I will be covering more videos on every topic, and so that your questions should eventually